All right, let's just jump right in. Welcome to this explainer. Today we're unpacking something truly mind-boggling, how the Earth operates, not just as a random collection of isolated parts, but as one massive, beautiful, and deeply interconnected engine. We're going to look at exactly how energy from the sun and the matter right here on our planet continuously flow and transform to create the world we live in.
To get our gears turning right off the bat, think about this ripple effect for a second. If we clear out a massive forest, how does that actually alter the flow of a river miles away, or even change the local weather? Well, when we remove trees, we aren't just changing the scenery. We're drastically decreasing plant transpiration, which directly leads to a drop in local rainfall. Without those roots locking the soil in place, erosion spikes, which muddies the rivers. It's a perfect example of how pulling just one thread can unravel a whole system. Here is our quick roadmap for today's journey. We'll start with Earth's interconnected spheres, move on to the power of uneven heating, explore winds and ocean currents, dive into the cycles of life, and finally wrap up with our impact on the system. Section 1, Earth's interconnected spheres. Basically, the parts of the engine. Let's dive into the foundational pieces that make up our world. So our planet is essentially made up of 5 distinct yet completely intertwined spheres. You've got the geosphere, which is the solid rocks and soil like the Deccan Plateau, the hydrosphere, containing all liquid water like the Ganga-Brahmaputra river system, the cryosphere, our frozen world of Himalayan glaciers and polar ice, the atmosphere, the protective blanket of air we breathe, and of course the biosphere, encompassing all living things from mangrove forests to coral reefs. Now the really fascinating part is how they talk to each other. If you tweak just one thing, say less snow in the cryosphere during winter, it kicks off a huge chain reaction. Less snow means less melting water for the hydrosphere's lakes in the summer, which means less grass growing in the biosphere to feed local sheep. Moving on to Section 2, the power of uneven heating, or what's fueling the system. What exactly powers all these moving parts, and why on Earth isn't it distributed equally? 1.4 kilowatts per square meter. That is a staggering amount of energy. We actually call this the solar constant, and it represents the raw, unfiltered solar radiation arriving at the very top of our atmosphere. Before clouds scatter it or the ozone absorbs it, this is the sheer power the sun is blasting our way. Way back in the 1950s, pioneering Indian atmospheric scientist Anamani actually mapped the solar insolation all across India. Her measurements proved India's immense renewable energy potential decades before modern solar farms were even a thing. This energy right here is the ultimate fuel for our planetary engine. Now, this brings us to a super important concept called albedo. Think of it simply as how reflective a surface is. Notice how snow and ice act like giant blinding mirrors? They reflect up to 90% of the sun's energy straight back into space, which keeps polar regions freezing cold. But low albedo surfaces like dark ocean water or black soil, they just absorb that radiation, heating up incredibly fast. It's exactly why walking barefoot on black asphalt in July feels like stepping on a hot frying pan compared to walking on a bright, snowy field. Because we've built our modern world with so many of these low albedo materials, we've actually created our own localized climate changes. If you've ever felt that suffocating heavy heat inside a concrete city at night, you've experienced this firsthand. It's called the urban heat island effect. Cities are packed with asphalt and concrete. All day long, they soak up the sun's radiation like a giant sponge. Then at night, they release it, making urban centers significantly hotter than the surrounding rural areas, which get to rely on the natural shade and cooling transpiration of plants. Which leads us perfectly into Section 3, winds and ocean currents, the pistons and gears of the machine. Let's see how this uneven heating actually gets things moving across the globe. Think about a mountain slope facing the morning sun. A simple 3-step process creates what's called a valley breeze, and it's a perfect example of how temperature differences act as localized atmospheric pistons. Step 1. The slope heats up rapidly during the day. Step 2. The air right above it gets warm, expands, becomes lighter, and floats up just like a hot air balloon, creating an area of low pressure. Instantly, Step 3 kicks in. The cooler, heavier air resting down in the valley rushes up the slope to fill that empty space. Boom, you've got wind. It's the exact same thermal logic driving those nice land and sea breezes on the coast. Now let's zoom out to a macro planetary scale. The equator is absolutely hammered with direct sunlight, right? So that warm air rises and heads out toward the colder poles. But because the Earth is constantly spinning, this moving air doesn't just travel in a straight, simple line. The rotation deflects it, creating these huge, curved planetary wind belts. And as these winds blow, they drag the surface of the ocean right along with them, creating massive rotating ocean currents known as gyres. This incredible circulation distributes heat from the sweltering equator to the freezing poles. It is so powerful that a warm current called the North Atlantic Drift literally keeps ocean ports in Europe completely ice-free, even in the absolute dead of winter.
All right, Section 4, the cycles of life, the oil keeping everything running smoothly. The big takeaway here is that all this physical movement of wind and water across the globe is what drives the biogeochemical cycles that actually keep us alive. Think of these as the Earth's ultimate recycling programs. Essential nutrients are relentlessly passed back and forth between living organisms and the non-living spheres. Water evaporates from the oceans and rains down on the land. Carbon is inhaled by plants through photosynthesis and exhaled by animals. Nitrogen in the air is fixed by soil bacteria so plants can actually absorb it. It's a delicate, billions of years old balancing act ensuring that matter is never really created or destroyed. It just constantly changes hands. Let's zoom in on the carbon cycle for a second, because it actually operates at two totally different speeds. The fast cycle is what's happening right in your backyard right now. Plants breathing in CO2 to grow leaves, caterpillars munching those leaves, birds eating the caterpillars and breathing CO2 back out. That takes days, maybe years. But the slow cycle, that takes literally millions of years. Dead plants and marine life get buried deep in the geosphere, slowly compressing into fossil fuels. Nature is brilliant at balancing both of these speeds. But when we come along, dig up that ancient coal and oil and burn it, we are taking millions of years of slow cycle carbon and dumping it straight into the fast cycle atmosphere in the blink of an eye. And get this, an astonishing 1 to 2% of the entire world's energy supply is used for just one single thing, the Haber-Bosch process. See, the air around us is 78% nitrogen, but plants can't absorb it directly. So we invented a massive, highly energy-intensive artificial way to pull nitrogen straight from the air to manufacture synthetic fertilizers. It literally feeds billions of people today. In fact, there is a very good chance that more than half the nitrogen atoms in your own body right now came out of a Haber-Bosch factory. But, as we're about to see, this kind of intervention comes at a cost to the wider system. That brings us to Section 5. Our impact on this system, or throwing a wrench in the gears. We need to take a really objective look at how human activity is disrupting these beautifully balanced natural cycles. Since just 1960, atmospheric carbon dioxide has surged by an unprecedented 35%. Scientists track this on a very famous graph called the Keeling curve. We've shot from 315 parts per million up to 420 in just a few decades. Remember that greenhouse effect? Carbon dioxide acts exactly like a blanket, trapping the infrared heat that the Earth is trying to radiate back into space. This 35% spike is intensely amplifying that blanket effect, rapidly melting the cryosphere and totally scrambling our global weather patterns. And the hydrosphere is taking a massive hit here too. Usually, the oceans act as a giant carbon sink, soaking up a lot of that excess CO2. But here's the physics problem. Warmer water holds less dissolved gas. So as the oceans heat up, their ability to act as a carbon sink just plummets. Plus, the excess CO2 they do manage to absorb chemically turns into carbonic acid. This chain reaction increases ocean acidity, which directly threatens the survival of tiny bottom-of-the-food-chain plankton and literally dissolves the calcium structures of massive coral reefs. Now, let's circle back to that artificial nitrogen fertilizer we talked about. When we over-fertilize our crops in the geosphere, the rain washes that excess nitrogen straight into our rivers and lakes. This triggers something called eutrophication. Basically, it causes an explosive, widespread growth of algae. When that massive algal bloom inevitably dies and decomposes, the whole process sucks all the available oxygen right out of the water, quite literally suffocating the local aquatic life. So an action on a farm on land inadvertently destroys a fishery in the hydrosphere. Everything really is connected. But hey, it's not all doom and gloom. We absolutely have the power to course correct, and international scientific cooperation proves it. The Montreal Protocol successfully phased out harmful chemicals, and today it is actively healing the hole in our ozone layer. And initiatives like India's Mission Life emphasize that mindful, eco-friendly lifestyle changes on an individual level genuinely, measurably matter. Simple habits, conserving energy, shifting to renewables, planting trees, these can collectively help restore this giant planetary engine. So as we wrap up this explainer, I really want to leave you with a provocative question to chew on. What daily habit might you change today to help protect the Earth's delicate balance? Because the future of our incredible, deeply interconnected Earth system, the air we breathe, the water we drink, the climate we rely on, is quite literally in our hands. Think about how you're interacting with the spheres today. Thanks so much for learning with me.